All right, welcome to week 7 practice problems. Let's go ahead and get started. First question says the sum of two roots in a certain equation is -2, and the product of its roots is -3. Which of the following could be the equation? All right, so a couple choices here. We could actually, factor each of these equations, right? Looking for numbers like in A, if we have x squared plus 2x minus 3, we could look at the factorization of this thing. Numbers that multiply to be -3, -3 that add to equal 2. Well, that would be, let's see, multiply to be -3 and add to be 2. That'd be -3, +3 and -1. So we have x plus 3x minus 1. If I set each factor equal to 0, I see that -3 is a solution and +1 is a solution. Remember, all I'm doing is setting each factor equal to 0 and solving. I get x is equal to -3, and if I add 1 to both sides, I get x is equal to 1. So those are my two solutions, -3 and 1. So the product of those is -3. So this times this, that's what this says here in the question. This is the product. So the product of the two roots, that is -3. What do they add to be? The sum of the two roots is -2. Those actually add to be -2. So the problem with this strategy is you'd have to try it for each one, right? And it's okay, but there's a faster way to do it. Remember the shortcut, the product of California and Sumba. So you have the sum of the two roots is -b over a, and the product is c over a. So in this, c is going to be -3, a is 1, so you get -3. -b, so -2 over 1 is -2. Okay, so that was obviously the best way to do that, is to remember that little shortcut. Alternately, you could graph, if you wanted to solve this thing with graphing, you could graph each one, graph the equation and then see where it crosses the x-axis. So basically you're finding the zeros of that function. And then you could just see which ones work. But then again, the whole point is that it takes too long to do that for each of the 5 equations. If E was the correct answer, you wouldn't know that until you get to E. I think this is obviously the fastest way to do it. All right, next question. What is the smallest value that satisfies the equation 3x squared minus 2x equals 1? Okay, so when it says satisfies, that means we're finding a solution. It's another one of those words that we see a lot. So basically, we have to solve this thing. So you can either get everything over to one side, okay, which means I'm going to subtract 1 from both sides. That makes a 0 on the right. Don't forget, this -1 is not an x squared term. It's not an x term. It doesn't have either of those things, so it can't be combined with either of these things that we already have, which means I just write it. Okay, now we got to either use the quadratic formula or factor this thing, or we can use a calculator. I'm going to go ahead and try to factor this. So I'm going to multiply that number over here. I'm going to get x squared minus 2x minus 3 equals 0. Factor it like normal. So the things that multiply to be -3 that add to be -2, that's -3 and +1. Don't forget, remember when we multiplied that 3 over, we've got to divide that out because we did something weird. That leaves x minus 1 and x plus 1/3. You move the 3 over, you get x minus 1 times 3x plus 1. You see what we did there? We moved our denominator over in front of the variable x. So that's our factorization. We set each factor equal to 0, and we're going to find our two solutions. We take away 1 from both sides. That gives us -1 equals 3 times x. Divide out the 3 on both sides. We get x equals -1/3. Over here, if I add 1 to both sides, I get x equals 1. So the question asks, what is the smallest value that satisfies the equation? The only two numbers that satisfy the equation are -1/3 and +1. So the smaller of those two values is -1/3. So we're going to say C is our correct answer, the smallest of those two values. Now remember, we could totally solve this with our graphing calculator. So if I look back to here, right here where I have everything over equal to 0, I can graph the left side and the right side here if I want. Okay, so I'm going to graph the left side. 3x squared minus 2x minus 1. Okay, then I graph the right side, which is 0. Then when I hit graph, I've got my left side, my right side. Now my zoom's messed up, so I'm going to go zoom 6, zoom standard. And I can kind of see that it's like 1 and looks like -1/3. Can I really tell what that is? See how the only answer choices are -4/3, -1, and -1/3? I can actually look at that and tell that that's -1/3. Okay. So in this case, I don't have to actually do the process of finding the intersection of these 2 points, but I'm going to go ahead and do it anyway. So second trace, let's calculate number 5, the intersection. Enter, enter, enter. There's my -1/3. Remember, to find the other side, I'd go second trace, number 5, which is intersection. Enter, enter, and then instead of enter a third time, I've got to get my cursor over here and then hit enter, and I get 1. So remember, I did that right here. I found my 2 solutions were 1 and -1/3. I just did that with the calculator. Also, I didn't have to do this part of the equation right here. Okay, I didn't have to do that part. I could have done from the very beginning. I could have done it 3x squared minus 2x equals 1. Graph the left side, graph the right side, it would have worked. Also remember, the other way to do it is to, instead of graph the left side, graph the right side. You just set everything equal to 0. You don't graph the right side, just the left side, but it has to be equal to 0. And then you find the zeros. So second, calculate number 2, the zeros. And we're going to find the zeros here. So left bound, right bound, and then enter. There's our -1/3. Okay. You do the same process for the other side, you get 1. Okay. All right, moving on. All right, 4i to the 6th plus 8i to the 4th equals. All right, so on this one, I've got powers of I. So, I can start listing out my powers of I. I to the first is just I to the second, that's -1. I to the third, that's -I. I to the fourth is +1. I to the fifth is I again. I to the sixth is I squared, which is -1. That's all I need to know. So I need to know I to the sixth and I to the fourth. All right. So I plug those in, I get 4 times I to the sixth, which is -1, plus 8 times I to the fourth, which is 1. That's -4 plus 8. That gives me +4. So my answer choice is D, +4. Now, sometimes the way I work this is a little different. I just look at powers of 2. There's I squared times, well, actually, let me write this out before I do this. So this is 4 times I to the 6th here. I basically have 3 I squareds, okay? Plus 8, and then I to the 4th. That's 2 I squareds. Okay, we know what I squared is. It's -1. So I can just replace each I squared with a -1, and this will work too. The 2 negatives make a +1, and then the other -1 makes a -4, and these 2 make a +1, so they just leave an 8, and I still get 4. So that's one way to think about it too, is how many I squareds do you really have? That's a good way to do it as well. Okay, so moving on. What is the largest root of x squared plus 10x plus 24? All right, so we're looking for the largest root here. So I would try to factor this thing. We're looking for numbers that multiply to equal 24, that add to equal 10. Numbers that multiply to be 24, that add to be 10. I think that's going to be 6 and 4. Okay, yeah, 6 and 4 multiply to be 24, they add to be 10. Means I get an x plus 6 times an x plus 4. So that means the roots are actually what would make the whole thing 0. So if I set it equal to 0, I realize that x plus 6 could equal 0, and x plus 4 could equal 0. That means that if I take away 6, I get x equals -6. So there's my first root. I take away 4 from both sides. I get x equals -4. So these are my two roots, -4 and -6. The question asks, what is the largest root? It's very tempting to say -6 because 6 is bigger than 4, but when you're in the negative, you want, if you have more of something, you have less negative. So actually, think about a number line. Here's -4, here's -6, right? Here's 0. This is a bigger number. -4 is a bigger number. So that's probably one that would trick a lot of people. It probably worked the problem out just fine, but they would answer -6. And of course, that wouldn't work. So there we go, -4, answer choice B. Don't forget, we can do roots on our graphing calculator. We just graph the equation, x squared plus 10x plus 24. Roots are the same thing as zeros. So when I graph this thing, I'm looking for the zeros. You can tell right here, -1, -2, -3, -4, and -6. Remember, you could look at a table to verify that. At -6, it's 0, and at -4, it's 0. You could also do the zeros by doing second calculate 0, left bound, right bound. So I'll go over here to, I'm going to figure out what this one is. Go to the left of my -4, hit enter. Go to the right, hit enter, and then get close and hit enter, and you'll find the 0 is -4. So lots of ways to do that one, okay? All right, find the sum of the roots of the following equation. -6 times x minus 3 times x minus 1 equals 0. All right, so when we think sum of the roots, sometimes we're like, oh, the sum is just -b over a, right? The problem is this is not in standard form, so we don't know a, b, and c. So you could multiply all those things out and you'd be able to find that. But I think in this problem, it's actually easier if you just think about how factored form works, right? The root is the number that makes the whole thing equal 0. So you see how if x was equal to 3, we would have -6 times 3 minus 3 times 3 minus 1. Would that equal 0? Yes, because this factor is 0. You'd have -6 times 0 times 2. Anything times 0 will be 0. That means 3 is a root. The other number that would work here is x equals 1. When you plug in 1, you get -6 times -2 times 0, and that does equal 0. So x equals 1, x equals 3. Sum of those roots is 4. Add them together, you get +4. Okay? You could graph this and see the roots, but it would, just take too much time. I think you really want to be able to look at factored form and know the roots almost immediately. Okay, it's whatever numbers make the factors 0. All right, for which values of x does -3 times x plus 1 squared plus 10 equal -17? Okay, for which values of x? That's asking you to solve the equation, okay? So we want to solve this equation. This is in vertex form. So remember, vertex form, I can solve like a normal equation. I get everything away from the variable, isolate the variable, solve for x, those things like we normally do. I can do that here. Just have to remember that when I take a square root, I get a positive and a negative number. All right, so let's start with the thing furthest away from the variable. That's the 10. I'm going to take away 10 from both sides. That's going to give me -3 times x plus 1 squared equals -27. Okay. Next, I'm going to divide out the -3 from both sides. That's going to give x plus 1 squared equals a negative divided by negative is a positive, and 27 divided by 3 is +9. Okay, so I'm going to square root both sides. Remember, squares and roots cancel. They leave us with x plus 1 equals 3. That's the only number, right? No, don't forget, you get a negative as well. So x plus 1 equals -3, okay? We just took the square root of a number. You always get one positive and one negative number, okay? So I solve both of these, take away 1 from both sides. I get x equals 2. There's my first solution. Take away 1 from both sides here. I get x equals -4. There's my other solution. So 2 and -4. 2 and -4 is choice B. All right? So B is our answer. Now, we could have graphed this using our graphing calculator, right? We could have graphed the left side and graphed the right side. This would have been pretty straightforward as well. So if I graph the left side, I get -3 times x plus 1 squared plus 10, and that's equal to negative 17. So I graph the left side, graph the right side. Now, when you graph the right side, you're not going to see that other line because it's too far low. It's y equals negative 17. That's down, down, down. So you're going to have to zoom out. So hit zoom 3, and then hit enter. There we go. There's our two intersection points. So remember, second calculate. Number 5, the intersection. And you can hit enter, 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 and it will pick one for you. There we go. X equals 2. Remember, we don't care about the y value. So x equals 2, right? That's that first solution we got here. The other one is they're going to intersect at negative 4. Second, calculate. Number 5, enter, enter, and then go over here, hit enter. You'll find that negative 4 is also the intersection point. Okay? Pretty straightforward. Anytime you want to solve an equation, you can always use your graphing calculator. All right, find b given that 10 minus 2b squared equals 3b squared. All right, so this one is a quadratic because it's got b squared in it, but it's not a quadratic in the sense that I have to use quadratic methods. If it only has an x squared or a b squared or whatever, it doesn't have an x term or a b term, you don't have to, you can solve this like normal. So what I'm going to do is get all the b's over together on one side. That's going to make 0. I'm going to have 10 equals 5b squared. Divide out the 5. That gives me 2 equals b squared. Now, when I square root the square away, that's going to cancel and leave me with b equals square root of 2. But you have to remember that also I get b equals negative square root of 2. Anytime you square root a number, you get 1 plus, 1 minus. So really, that's what they're saying here. It's plus or minus square root of 2. That's just the short way of, it's less writing. You see how this and this are the same thing, but this one took less writing. Mathematicians are lazy. We like to save time. So that's definitely why we write that, plus or minus root 2. So my answer choice A is going to be correct. Plus or minus root 2. Again, not to beat a dead horse here, but you could do this on here. You could graph the left side, graph the right side, and then find the intersection. Okay, just use x instead of b there. All right, simplify I to the 123rd power. All right, so I to the 123rd power. Don't forget, I to the 4th is 1, I to the 8th is 1, I to the 12th is 1. Any power of I that's to the 4th or multiple of 4 power, so 4, 8, 12, 16, 20, those all equal 1. So what you have to do is find basically the number that's closest to 123 that's a multiple of 4. In this case, it's 120. So we know I to the 120 is 1. Now let's say you didn't know that. Maybe it was a weird number. You could take 123, whatever that number is, and just divide it by 4. Okay, that means there's 30 multiples of 4, and then there's some left over. So then you take your 30 multiples of 4, and you say, well, what number would that be? Oh, it's 120. Okay, that means there's that 120 is your closest number. Then you just kind of count on. So 121, that's going to be the same thing as 120 times another I. So that's going to be I. Okay. I to the 122nd power is going to be I times I. That's I squared. That's negative 1. I to the 123rd is going to be negative 1 times I. So it's going to be negative I. So we get B. B is the correct answer there. All right. All right, a rectangular picture frame is x plus 7 feet wide and x plus 1 feet high. If it has an area of 40 square feet, find the width in feet of the picture frame. All right, so let's draw a picture here. It's always good. I've got a rectangular picture frame. It's x plus 7 feet wide and it's x plus 1 feet high. Has an area of 40 square feet. So 40 square feet. We want to find the width in feet of the picture frame. So basically, what I want to know is how wide is this thing? This is the thing I want to know. Okay, that's my ultimate goal, is to find that length. So this looks like an easy problem. It's the area of a rectangle is the length times the width. So fill in everything that you know with this formula. The area is 40. Okay, the length is x plus 7. The width is x plus 1. I guess technically we're doing width and height. It's the same thing, though, width times height. It's the two dimensions that you have. So the width is x plus 7, the height is x plus 1. So then basically multiply this stuff out. 40 equals, right, we distribute our x, you get x squared plus 1x. Distribute your 7, you get plus 7x plus 7. That's a quadratic function, right? You got x squareds and x's. Two choices. You could, well, first off, let's simplify this. X squared plus 8x plus 7 equals 40. Right now, I could get out my graphing calculator, graph the left side, graph the right side, find the intersection point, I'd be done. Okay. Alternately, you could get everything on one side, so subtract 40 from both sides. That gives you x squared plus 8x minus 33. Okay. And then we could factor this, or we could plug it into the quadratic formula. Either way works. I'm going to try the quadratic formula here just because, why not? All right. So using your graphing calculator, all right, I make a fraction first. So alpha y equals, and then enter. There's my big giant fraction. So negative b is 8. So negative b is negative 8, plus or minus. I'll do the plus first. The square root, so second square root of b squared. B was 8, so 8 squared minus 4 times a, which is 1, times c, which is negative 33, all over 2a, so 2 times 1. I don't have to do the times 1, it's already going to be 2. And then I hit enter. There we go. There's my first solution, 3. So 3 is my first solution. All right, next I go back up, right? Hit up, and hit enter. I just repeat the process, but I do it with the minus this time. So it's negative 8 minus all this stuff. So just change that to a minus, hit enter. There's my other solution, negative 11. Now remember, I could have factored this into x plus 11 times x minus 3, and then I solve that, I'd get 3 and negative 11. It's the same thing I would have done if I would have factored it. Let's think about this. So that means if x is 3, this is 4, because that's 3 plus 1, and this is 10. All right, that's if x is 3. I get a 4 by 10. That makes where I get 40 square feet. What if x was negative 11? I'd get, let's see, negative 11 plus 1, that's negative 10. By, this would be negative 11 plus 7, that would be negative 4. So you can't have negative lengths. So we actually just ignore that side. We just worry about the positive version here. So 4 times 10. Question says, find the width. Well, the width is this orange side, which is 10 feet. So E is our answer choice. That is correct. Okay, just remember, you got to think first off from the very beginning. I've got to set up an equation to solve. So think about this. This is an area of a rectangle. We know that equation. Area equals width times height. Bam. Fill in with what you know, and then just solve for x. Okay, that's a big part of math and the ACT. All right, next question says, simplify 2i times 3 minus I. All right, so 2i times 3 minus I. If I'm looking at this problem, it looks like I should distribute, right? Because I've got 2 terms inside of parentheses with a product, a multiplier out front. So I just do that, 2i times 3. Remember, guys, this works just like x's. Okay, you can work i's just like x's. What would 2x times 3 be? Be 6x. What would 2x times minus x be? Be minus 2x squared. But when I do the i's, it works the same way. 2i times 3 is 6i minus 2i squared. See how they're basically the same thing? So whenever you're working with i's, just think about it as in terms of x's. So I get 6i minus 2. Remember, I've got an I squared. That really means negative 1. Make that little substitution there. Then I simplify 6i. Negative 2 times negative 1 is positive 2. Then look for your answer choices. Your answer choice E is correct. Remember, a lot of the times they'll write it as 2 plus 6i. It's the same thing. Yeah, with addition, you can switch the order of things. There we go. All right, which of the following graphs has 2 imaginary solutions? All right, So remember, here's the only three choices. You can have two real solutions, right? That's when you have the graph hitting the x-axis twice. You can have one real solution. That's when it just touches it and moves on, just touches it one time. And then you can have zero real. And when you have zero real, you always have two imaginary solutions. And that's when it doesn't appear to cross the x-axis at all. So what we're looking for is the only graph that doesn't cross the x-axis. So that is going to be C. C will have two imaginary solutions. C will not factor. If you're solving an equation that makes the graph C, you'll have to use the quadratic formula and you'll get those two imaginary solutions. You'll get the square root of a negative number, which will give you imaginary solutions. All right, find the largest solution to the equation x squared minus 6x plus 3 equals 0. All right, so the largest solution to the equation. So we're solving this thing. So I'm going to go ahead and just go straight to my graphing calculator here. I'm going to find the zeros. So I'm going to graph the equation and then find the zeros. So I go to y equals, clear everything out. All right, x squared minus 6x plus 3. I want to know when it crosses the x-axis. So there's my 2 points. I'm going to go back to Zoom standard. There we go. A little less than 1, a little bigger than 3, 4, 5, a little bit bigger than 5. So I can tell my smallest one is going to be less than 1, but it's going to be a positive number. So that helps me eliminate choices A and B, right? Because A and B are both negative numbers. So I can cross them out. Narrows it down at least pretty quickly. All right, so let's see. Let's do second, calculate number 2, the 0. There's my left bound to the left of my 0. Enter and then enter. All right, so 0.5505, 0.5505. Now I don't see that on here, but remember I can convert anything I want to decimal. So I can go and type all these things in. 3 minus root 6. Okay, with my calculator, go back to second quit. That gets me back to my calculation. 3 minus second square root of 2. 3 minus root 2 is 1.5. Oh, sorry, it's root 6. So 3 minus root 6 is that number. So perfect, that's my choice. Choice C. Okay, didn't have to go any further there. So really, that's one way to solve this problem, is to just get out your graphing calculator, find the solution, you realize it's a decimal, so then you just convert your answers to decimals. Alternately, we could just solve this by factoring, okay? What two numbers multiply to be 3 that add to be negative 6? Well, the only numbers that multiply to be 3 are 3 times 1. So it could be negative 3 times negative 1 or 3 times 1. Either way, those numbers are not going to add up to be negative 6. What does that tell me? It tells me it does not factor. Okay, so that means I should then use my graphing calculator or just work it by hand, but either way I should use the quadratic formula. So x is equal to negative b. Well, b is negative 6. I'm going to write these out. A is 1, b is negative 6, and c is positive 3. So negative b is going to be 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a times c, all over 2a. Okay, so 6 plus or minus the square root, negative 6 times negative 6 is 36. 4 times 1 times 3 is 12, divided by 2. Now remember, this would have been easy to do on your graphing calculator. You could have just typed this in. It would give you that decimal. You go back and figure out which ones match with the decimal. But this way we'll actually get our answer with the square root in it. All right, so we get 6 plus or minus the square root of 24 divided by 2. All right, so square root of 24, remember we can break that down into products. It's the square root of 4 times the square root of 6. Square root of 4 is just 2, and the square root of 6 doesn't break down any further. So really 2 square roots of 6 is what square root of 24 is. So we really get 6 plus 2 square roots of 6 divided by 2. Now, this is our answer. We get 1 plus 1 minus. So obviously the smaller one is going to be the one with the minus. But none of our answers look like our answer choices. That's because there's a product, there's a factor of 2 in every single term. So what we do is we factor out a 2 from the top. That leaves me with 3 plus or minus root 6 divided by 2. Then we cancel the 2's. Then we get our final answer. 3 plus root 6 and 3 minus root 6. Those are my two solutions. Now, of course, the smaller one is going to be the one where you take away the root 6 from the 3, not adding it to the 3. Okay? So that's how you would do that kind of the original way. Now, really, honestly, man, this might be faster on your graphing calculator than doing it the old school way. But it's a preference. If you'd rather work it out by hand, if you're good with quadratic formula, I'd say work it out. Okay, if m is equal to 3 plus I and n is equal to negative 2 plus 2i, find m divided by n in simplest terms. All right, so we've got two complex numbers here, and it asks us to find m divided by n. So m divided by n is 3 plus I divided by negative 2 plus 2i. Okay, anytime we divide complex numbers, or if we just have some kind of complex number where there's an I on the bottom, we always multiply by the conjugate, okay? Remember, the conjugate is whatever the bottom is. So the conjugate of negative 2 plus 2i would be negative 2 minus 2i, right? You just switch the middle sign there. That's the conjugate. So this is our conjugate. All right, so we're going to multiply by the conjugate on the top and the bottom, right? We're just multiplying by 1, this really weird version of 1. If you take an expression like 3 plus I over negative 2 plus 2i, you multiply it by 1, it doesn't change. It may change the way it looks, but it doesn't change its value. All right, so we've got to do a lot of distributing here. We're going to distribute the top and distribute the bottom. So 3 times negative 2, that's negative 6. 3 times negative 2i, that's negative 6i. Then we distribute the I times negative 2 is negative 2i. I times negative 2i is negative 2i squared. Okay, that's the top. Then we distribute the bottom. Negative 2 times negative 2 is positive 4. Negative 2 times negative 2i is positive 4i. 2i times negative 2 is negative 4i. Notice our i's are going to cancel there. That's always what should happen when you multiply by the conjugate. That's why we multiply by the conjugate. And then finally, positive times negative is a negative. 2 times 2 is 4. I times I is I squared. All right, we got to do some major simplifying here. Looks like on the top, I've got 2 different i's that could come together. That makes negative 8i. I've got a negative 6 before that and a negative 2i squared after that. On the bottom, my I terms cancel. I'm left with 4 minus 4i squared. All right, and anytime you see an I squared, you've got to change that to negative 1. Okay, so I'm going to work over here now. I get negative 6 minus 8i minus 2 times negative 1. That's my I squared. Divided by 4 minus 4 times I squared. And again, I put negative 1 for I squared. Okay, I can combine these two as multiplication. Negative 6 minus 8i plus 2 divided by 4 plus 4, right? I've got a negative 4 times a negative 1. That makes a positive 4. Combine my numbers up top. Negative 6 plus 2. That's going to be negative 4 minus 8i divided by 8. Now, this is almost a complex number. We've got to separate the top into 2 parts and take the bottom and bring it to both parts as well. So I really want to write negative 4 over 8 minus 8i over 8. Then we just simplify that. So we get a half as our real part, and then our 8's cancel here to leave minus I. So 1/2 minus I. That is our answer there. So, oh, sorry, negative 1/2 because there's a negative 4 divided by 8. So negative 1/2 minus I. Answer choice E is going to be correct. All right. Next problem. How many real solutions does the following function have? F of x equals f of x equals 3 times x minus 5.5 squared plus 10. All right, so this is asking how many real solutions does it have? So I think back to, how many times does it cross the x-axis, okay? Now, thinking about this form, what form are we in here? That looks like vertex form. So vertex form is always the easiest number to plug in here, and then the number that remains. So I can plug in a 5.5, and that would make the whole first part go away. And then that would leave me with 10. So 5.5 comma 10 is my vertex. So 5.5, 10, bam, there's my vertex, okay? Now, if I think about this, this thing opens up because A, the number 3 is positive, and it's positive 3. So over 1, up 3. Over 1, up 3. So this is actually a pretty decent graph of what it looks like. So I can tell from right there, there are no real solutions, right? E is going to be my answer choice. There's no real solutions because it does not cross the x-axis here, okay? Remember, you could, if you did not feel comfortable, I would just graph this thing. Go to y equals, graph it, see what it looks like. Same thing, right? I'm just using the fact that I know how to use vertex form to graph it pretty accurately, okay? All right, if A equals 3 minus 2i and B equals 5 plus 4i, what is 2b minus A? All right, so 2b minus A. So 2 times B minus A. Well, B is 5 plus 4i, and A is 3 minus 2i. Notice I'm using parentheses around these because I need to distribute the 2 to both parts. If I don't put the parentheses, I won't see I have to hit both of them. Same thing with the minus. I'm subtracting the entire thing A. So I have to make sure I distribute that negative sign. So distribute your 2, you get 10 plus 8i. Distribute your negative, you get minus 3 plus 2i. Combine your like terms, 10 minus 3 is 7. 8i plus 2i is 10i. And there's your complex number that you get after you add and subtract these complex numbers together. So answer choice B, 7 plus 10i is correct. All right, for what imaginary values of x does negative 7 equal x plus 1 squared plus 5? All right, so they're kind of hinting, they're telling you that you're going to have imaginary solutions, okay? We are in vertex form, so I would try to solve this thing like you can with vertex form. Remember, let's actually try to use our graphing calculator here. Let's see what we get. We're going to graph the left side, negative 7. Okay, so we graph the left side, negative 7. Then we graph the right side, x plus 1 squared plus 5. X plus 1 squared plus 5. And we hit graph. There's 1, there's 1. They do not intersect, which means they do not have any real solutions. That's why they're saying imaginary here. We cannot use our calculator on this one. There's no way to do it, fortunately. So here's what we're going to have to do. We're going to have to solve this thing like it's a regular equation because it's in vertex form, and that's how we solve vertex form. So I'm going to take away 5 from both sides. That gives me negative 12 equals x plus 1 squared. Okay, now I can square root both sides. The square and the square root cancel, x plus 1. Square root of negative 12. Okay, here's how this works. Basically, you pull out the negative with an I. And then you still have the square root of 12 left over. Okay, the square root of 12 does break down. It's 4 times 3. Square root of 4 is 2. Square root of 3 does not break down. That's the version you want to think about. So really, it's 2i times the square root of 3. I just squeeze the I in there because I see my answers have that, right? My answers all have the 2i together. You could write 2 square roots of 3 times I, or I times 2 square roots of 3. It doesn't matter what order you put it in, as long as they're all there. So we get that equals x plus 1. Don't forget, there's actually another solution here because we just took the square root of a number, right? When we take the square root of a number, we get 1 plus and 1 minus. So 1 plus and 1 minus. Then we have to solve for x. We have to take away 1 from both sides. That's going to leave me with negative 1 plus 2i root 3. Over here, when I take away 1, I get negative 1 minus 2i root 3. Those are my two imaginary solutions. So choice E is the correct answer. Okay, that one's tough, but you just got to be comfortable. I think the only weird thing is the root 12 means root 12 times I. That's where that negative pops out. Okay, because basically root negative 12 is root 12 times root negative 1, and that's where we get the I from. Okay, All right, what is the product of the two solutions to the equation 8x squared equals 3 minus 10x? All right, so on this one, I would definitely realize that we're looking at the product of the two solutions, which is really the product of the roots. Remember, roots and solutions, zeros, x-intercepts, all those things, they mean the same thing. So I would get it into standard form. I would add 10x to both sides. And then I would take away 3 from both sides to get everything on one side, right? I did minus 3 plus 10x. That gives me this right here. Okay, these cancel and leave you with 0. So now I know what A is, I know what B is, and I know what C is. A is 8, B is 10, and C is negative 3. The product of roots, remember the product of California is C over A. So negative 3 over 8. That's it. It's B. That's easy, right? Get it all over to one side so you can use A, B, and C, then use product of California. Of course, alternately, you could have graphed the left side, right? 8x squared, 8x squared, and then on the left side, you had 3 minus 10x. Graph them, bam, bam, they intersect twice. Second, calculate number 5, the intersection. Oops, something went wrong there. Second, calculate number 5, intersection is 0.25, so that's 1/4. Okay, 1/4. And then the other one is second, calculate. I think it's not going to work here. See how you can't see it? We're going to try enter, enter, and then we're going to get close and hit enter. I did find it. So negative 1.5. So negative 1.5, that's negative 3/2. You can convert that using your graphing calculator, right? Negative 1.5 math, enter, enter. That turns it into a fraction. There's your negative 3/2. So we have 1/4 times negative 3/2. That gives me negative 3/8. But I think my way from the very beginning is obviously the faster way. So just remember that shortcut, okay? All right, what is the larger of the two zeros of the function h of x equals negative 2x squared minus 10x minus 8? All right, a lot of ways to do this. Quadratic formula, you could factor, or you could use your graphing calculator. If you factor, remember you've got that a is equal to negative 2, so you multiply it over. Minus 10x, that's plus 16. You factor like normal. You get x minus 8 times x minus 2. They multiply to be 16, but they add to be negative 10. Then you divide back that negative 2 that you, oh, see, I'm doing it wrong. This is good. This is good for me to do it wrong. You subtract, you get x minus 4, and you get x minus 1. And you would think, oh, there we go. I got my answer. Okay. What did I do wrong here? Well, first of all, this should be a plus and a plus because there's 2 negatives. But that still doesn't mean that I did it right. If you multiply that back out, you do not get back to where you started. Why? First thing you do when you factor is always look for something to pull out. What is it? GCF, greatest common factor. If you don't pull out the GCF, this won't work. This will mess up like it just did. So let's go back to the very beginning, okay? We're going to start with negative 2x squared minus 10x minus 8. We're going to look for that GCF. So what is the GCF here? GCF is negative 2, right? You see how there's a negative 2 in everything? There's a product of negative 2 in everything. So that leaves plus 5x and then plus 4. Now we've got our GCF. Okay? All right, so x plus 1 times x plus 4. We get that x is equal to negative 1 and x is equal to negative 4. Those are my two zeros, my two solutions. Right? Don't forget, I'm just setting each factor equal to 0. And when I do that, I take away the 1, I get the negative 1. And when I do x plus 4 equals 0, if I subtract the 4 from both sides, I get x equals negative 4. Negative 4, negative 1, what's the larger? Remember, this is a trick question almost. It's negative 1 is bigger than negative 4. It's better to have owing somebody $1 than owing somebody $4. You actually have more money if you only owe $1. This would have been a great one to use the graphing calculator, right? Just find the zeros. You either set the graph equal to 0 and find the intersection, or you just leave it like it is, graph just the one side, then find the zeros, okay? All right, what is the smaller of the two zeros of the function p of x equals x squared minus 10x? All right, so smaller of the two zeros. Let's try our graphing calculator here. Okay, we're looking for the zeros. So I have two choices. I can graph it like it is. Okay, x squared. Let's start over. Okay, x squared minus 10x. All right, I graph this thing. Second trace, number 2, finding the zeros. Remember, you got to do a left bound. So get to where you think the 0 is, hit left a few times and enter. There's my left boundary. Make sure you're to the right of the 0 and hit enter, and then basically hit enter again. There's my first 0. So x equals 0. That's my first 0. The second 0 is over here. I think I can actually look at the table on this one. See how 0 makes a 0? The fact that the y is a 0 means it's a 0. And then I think, again, at 10 makes a 0. So 10 is going to be my other one. Remember, just do second calculate 0 if you're not sure. X equals 10. Those are my two zeros. The smaller one is going to be 0. Alternately, this one would have been an easy one to factor because you look for the greatest common factor. There's an x in everything. So you factor out an x. We're looking for zeros, so we set it equal to 0. Let the first factor equal 0 and the second factor equal 0. This gives you 10. This gives you 0. Same thing. Okay. All right, what is the smallest possible solution to x squared minus 10 equals negative 6? All right, so we're looking for the smallest possible solution. Probably going to get two solutions, and we'll just pick the smaller one. Now, on this one, I could use my graphing calculator, graph the left side, graph the right side. It'd be pretty simple. Or alternately, I realize this just has an x squared, not an x, so I can solve it like a regular equation. So I'm going to take this, and I'm going to add 10 to both sides. Okay, that gives me x squared equals 4. Square root both sides. Excuse me. Square roots and squares cancel. We leave the square root of 2 as 2. Here's the only problem. There's two solutions here because the square root of 4 is 2 and it's negative 2. If you didn't remember that, this problem would trip you up because you would answer 2 right here, D, but it would be wrong because you've got to have the negative version as well. So you do get negative 2 as your solution. Okay. Just to make sure you really get this, graph the left side, x squared minus 10. Graph the right side, negative 6. Boom, boom. They intersect right here at negative 2 and over here at positive 2. You can see that from the table. See the y values are equal at 2. They're both negative 6. And at negative 2, they're both negative 6. Okay, alternately, second calculate number 5, the intersection, you know, first curve, second curve, and then move over to the intersection or at least close. Hit enter, there's your negative 2. Second calculate number 5, enter, enter, and then get close to your other one. Whoa, there we go, x equals 2. All right, pretty straightforward. All right, there was one more. I think I double hit it there. There we go. Okay, find all possible solutions to the following quadratic equation. 0 equals x squared minus 2x plus 2. All right, so we're going to try to factor this thing. Two numbers that multiply to equal 0, excuse me, multiply to be 2, that add to be negative 2. Okay, only 2 and 1 multiply to be 2. But they don't add to be negative 2. What if they're both negative? They'd still multiply to be negative 2 or positive 2, but they can't add. Okay, this does not factor. So next thing I maybe try is my graphing calculator. Okay, I'm going to graph 0, and I'm going to graph x squared minus 2x plus 2. All right, so y equals, I'm going to graph the left side, then I'm going to graph the right side. So x squared minus 2x plus 2. All right, so where do they intersect? Okay, they don't intersect. Well, if they don't intersect, that means there's 0 real solutions. So A and B cannot be my answers because those have 2 real solutions. They're impossible. It's got to have some kind of imaginary solution. So what I'm going to have to do here is quadratic formula. Negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So what is a? A is the coefficient of the x squared term. It's 1x squared. B is the coefficient of the x. It's negative 2x. C is the constant term, the number. It's going to be plus 2. All right, so negative b. Well, negative 2, right? Negative b would be positive 2. Plus or minus negative 2 squared minus 4 times a1 times c2 all over 2 times 1. All right, I'm going to use my graphing calculator here. I'm going to go to second quit. I'm going to type this in. So make a fraction, alpha y equals, enter. Negative b, so 2. I'll do the plus version first. Square root of negative 2 in parentheses. You don't put parentheses there, it'll mess it up. Anytime you plug in a negative, always use parentheses, especially with your calculator, times a times c, all divided by 2a. Now I could just put 2 because I know 2 times 1 is 2. Hit enter, it says, in real mode, all calculations must result in a real number. Interesting. Error, non-real answers. Okay. So that means there's an imaginary number here. Oh, that makes sense, right? Because I already determined that because the graphs of the left side and the right side never intersected, I must have imaginary roots. Graphing calculator won't do this, okay? So we're headed back to this. 2 plus or minus square root. Negative 2 squared. Negative 2 times negative 2. That's always a positive. That's 4 minus 8 over 2. This is where you can tell I'm going to get imaginary solutions. This thing called the discriminant. It's the part under the root. It's negative. When it's negative, you're going to get imaginary answers. Okay? All right. So 2 plus or minus the square root of negative 4 over 2. Square root of negative 4, don't forget, is going to be the square root of 4 times the square root of negative 1. That's where my I pops in. Square root of 2 is 2. So I get 2i. Okay? So 2 plus or minus 2i divided by 2. Everything has a 2 in it, so I could factor out a 2. That leaves 1 plus or minus I divided by 2. 2's cancel. I'm left with 1 plus or minus I. So there we go. That's my solution C. 1 plus or minus I. Okay? Now, if you're brave, you could plug this back in. You could plug this back into x squared minus 2x plus 1, and you would see that it actually works. It's pretty crazy. But it should work there. All right. That's all I got for this week. Thanks for being here. We'll see you next week.